Welcome back, my friends. We are looking to enhance the Metro Map project from the WiByte Python curriculum available at www.wibyte.in. Now, recall Metro Map is this very interesting project inspired by metro trains that run around the world. So we come here to the WiByte Metro. There are two lines. We have these lines displayed on the GUI. We pick up whatever lines we want to start from. Say, for example, we want to go from cloning to, let's say, station called, let's say, escape character. Now, when I say calculate fare, it tells me, well, it's 60 rupees because right now my fare is 20 rupees per station. So there should be a unit over here, but that doesn't matter, right? So it's basically cloning. I go to WiByte. I switch to, for example, the blue line. I go to while loop and then go to escape character. So this is really quite, realistic in some sense because this is how metro systems are. And of course, you can enhance this in umpteenth number of ways. We'll start seeing that in this video. The first enhancement we are going to look at is how do I place lines a little bit more differently. Notice my lines are perfectly sort of vertical and horizontal, but how can, for example, I make them, let's say, a little bit more inclined? Now, you might wonder, why would I ever want to do this? But as we saw in examples earlier, cities are laid out differently, which means sometimes we want to to put these lines in a way that reflect how cities are made. So a first step towards that is, well, making these lines, let's say, inclined. So I'm going to show you how in this video. I'm going to place my orange line, which is the scratch line, by, let's say, in sort of going upwards, and the Python line, which is the blue line, will be going a little bit sort of diagonally downwards. Now, of course, this is just an example. You can further modify this and place these lines in whichever way. Now, the idea really is to create a function with which we can place these lines on the canvas. Remember, previously we had a code of, let's say, this sort. We decided, all right, what is the starting position, ending position, what's the distance between stations, and so on. Now, we did this for both the lines. For example, scratch line and the Python line. We ran a for loop and we created oval and text. And of course, we changed the X and Y accordingly. Now, we are going to generalize this by creating this into a function because that will become quite powerful. This slide is rather, let's say, busy, lots of things on this, but see it carefully. Basically, I'm saying, okay, let me define a function called draw metro line. I pass in station list as an argument, so it could be station, let's say, scratch line or let's say Python line. I decide the initial x and y coordinates of the first station, so that's my x's and y's. I send it as a list, let's say, or it can be a tuple as well. So I say, okay, 0 is x, 1 is y. I tell what is the separation on the x side and on the y side. So I say, okay, x step is, let's say, step 0, y step is step 1. And then I tell how far away should these labels be. So now label offset is basically, again, a list, 0 and 1. So basically label offset on the x is the x side and the y side. And finally, the radius of the station and the color of the line. So you can see that this will generalize this. This part of the logic is pretty much what we had done earlier. So let's just do this first, and then we'll see how this becomes quite useful. So I get into my code here. I will just, in fact, copy some part of the code so that I can, reuse it because the code is really quite similar to what we had done earlier. So let's just see, for example, here, I'll just take, let's say, this piece of the code. I'll just copy this. And now I'll use this in my function. Of course, I'll have to change certain things as I, write the function. So I come in here. I say, well, let me first paste this here. Be very careful with this because now we've got to make some changes. So I'm going to say, well, drift, let's say, draw, let's say, metro. Okay, so draw, let's say, metro, let's say, lines. Now, several inputs to this. For example, I have the station list. I have what I call let's say, the init position, init, let's say, pause. I have let's say, the step, which is basically the distance between stations. I have the label, let's say, offset. Now you can name these things differently if you want to. I have the radius of the station. And finally, I have the color of the station. Now, this function must start with a colon. And obviously, everything that's inside the function must be indented. So I'm just going to take this right away and just indent it in one go. So that way it's nicer. It's already indented correctly. Let me just put this, a bit more clearer. Now, like I said, my initial position will contain the initial x and y. So I can just read that off this list. I say, well, init position, let's say 0. That's my x initial position. The y initial position is nothing but init, let's say, pause, say 1. Distance between stations, again, I'm going to split this into X distance and Y distance. So I just call it, let's say, I'm going to this to say X step. Now you can call it X distance, that's okay. And I call it, let's say, for example, step, say 0. And I'll do, say, Y step is step 1. Now this is very standard Python. Now we have seen this many times. We are going to send in step also as a list or say a tuple. Right now with this, I don't need to have the R station because that's coming in from the outside. Now over here, instead of doing this over, say, the scratch line, I'm going to say, well, do this whole process over the station list, whatever the station list might be. Unless I'm on the last station, draw me a line. So again, I change this to station list. Create a line again from XS, YS to XS plus, let's say, X step. So say X step and YS plus, let's say, Y step. Because recall previously we had only one distance because either the line went horizontally or it went vertically. But now I'm saying, well, it can be more flexible. So I can just specify, YS plus, let's say, Y step. So I'm saying, well, every point, look at the Y step, look at the X step, and accordingly draw a line. And the fill, again, obviously doesn't have to be dark, but in fact, it can be, let's say, CLR. Whatever color I'm passing, that makes it flexible. Now, having done this, I'm going to draw a circle with this create oval. Again, the fill of this must be equal to the color. That's all I need. As far as the label is concerned, previously I was putting the label, let's say, either below the line or let's say adjacent to the line. But here I'm saying, okay, let me make it flexible. Again, my label offset is, let's say, a list or say a tuple with two elements, X offset and Y offset. So I just go and say, well, label, say label offset, say 0. So that's a separation of the label on the X direction. And finally here, I just go and make it label, say offset 1. Now be careful about this. This is not very hard, but we still have to be careful because mistakes are possible, right? Text has to be station because that's STN, because that's the variable in the for loop. And finally the fill, I can make it, let's say, equal to the color. Now, having done this, my placement of stations has happened. But remember, previously I was drawing either I was changing either the X or the Y, but now I might change both. And what I will do is that I'll move to the next position, which is, well, change X by, let's say, X step, and change, let's say, Y by, say, YS plus, say, Y step. So it's like change X by X step, change Y by Y step. And this is really all I need. So now I have a function which can, let's say, draw these lines for me quite nicely. It is quite useful actually. Let's see it working. So what I'm going to do is that I'm going to first comment out, let's say, the placement for the scratch line. In fact, I'll just use a block comment over here. So I just go and, let's say, remove, some part of the code until, for example, let's say here. So my scratch line is not to be made anymore. I can verify that this part of the notice when I run this code, now the scratch line is not drawn. But what I will do instead is that I will use my function to now draw the scratch line at first exactly as I was doing earlier. So I'm going to say, well, draw the metro lines. Remember, this is a function that I've created. And, so it's called draw metro lines. I can probably make it draw, let's say, metro line, and I'll fix the name over there. So I say draw metro line, and the list I want is STN, for example, SL. I want this to start, remember, at 50 to 100. So that was my X and Y. So I just give it as a list, for example, 50 to 100. Remember, the first 0th item is X start. First item is, let's say, Y start. Having done this, I want to tell my, let's say, step. In this case, I'm saying, well, move only in the X direction of, let's say, 0, 0 in the Y direction. So basically 70, 0 as my step. For my label, I want to put the label below the line. So 0 offset on the X, but let's say 30 on Y. So these are all become lists now. Radius of the stations is going to be 6. And finally, let's say I'll put, color, say dark orange. Now, notice with just this one line, of course, I have to make sure that my function names match. I'm going to make this also say draw metro line. So there's no confusion. Now, when I run my code, I get back my scratch line as it was. In fact, now I can do the same exact thing to my Python line. So I'm going to say, well, let me comment out this part of the code because this is really quite, laborious in some sense. It's much better to do this with a function, just that we have to set these values a little bit more carefully because that is then flexible. Now I'll say, well, let me just, let's say, do once more. This time round, I will do this line for the Python line, so I call it stnpl. The starting positions, remember, is 330, 40. That's because, remember, this is the x side, to 330, 40 from top. So I will say, well, let me make it say 330 and let's say 40. The separation has to be this time around. Remember, there's no separation on the x because the line is vertical. But on the y direction, I have a separation of 70. Label offset, remember my label appears on the right side, which means label offset is, let's say, 40, 0. Same y position, but offset on the x side. And this I can make, let's say, for example, blue, because that's what I was doing earlier. Now, when I run this piece of code, my two lines appear exactly as they were appearing earlier. But the difference now is that my code is flexible. And using this, in fact, I can create almost anything. So let's now see what changes we can make to this. Remember, I wanted my scratch line to appear sort of going upwards. What I can do is that I can say, hey, look, the starting station should be a little bit lower. So I make it 300. Now, this calculation I've done before. Planning doesn't go away. I still have to plan this, but since I've done this before, so I say, okay, let me make this move down a little bit. Instead of just a separation of 70, I'm going to make it separation of 70 and minus 30. Now, this is to be very carefully understood. Remember, 0, 0 is on this corner. Y is increasing as we are going down, which means that if I'm saying separation of y minus 30, in fact, the line is going to go upwards. And that's what we saw earlier. In terms of label offset, I let them be so that the labels appear exactly as they were. So that is going to give me my scratch line. Let's just see until when I run this piece of code, notice my scratch line is now inclined. In fact, the WiByte position also looks nice, but I will adjust this a little bit. I'm going to go to my Python line. Python line, I want it to appear sort of, let's say, a little bit, diagonal again, crisscross types again. I am going to pull this thing in a little bit. So let's say I'm going to say instead of 330, let me make it, let's say 280. 40, I'm going to say, well, I need a bit more separation on the x. So instead of 20, instead of 0, I say 20. So it's a little bit, let's say, inclined. And my label offset remains exactly the same. Now, when I run this piece of code, I get exactly what I was looking for. In fact, WiByte also looks quite nice because it kind of indicates nicely that this is an interchange station and my both lines are crossing here. This is true many times in reality because whenever there's an interchange between two lines, sometimes you got to change floor, maybe go to basement or go to higher floor and so on. So this kind of indicates that very well, right? Now, you can imagine that this is very flexible. With this, you can add new lines, you can place them differently. For example, let's say I wanted a third line, which is probably, let's say, crisscrossing from, let's say, over here, and maybe costumes becomes a new interchange. You can definitely do that. You can still place these lines quite nicely because now the code is flexible. Yeah, the idea is very simple. The implementation is very beautiful, and I hope you found this interesting. In general, if you think this way of learning, where we are building activities that are realistic, that are connected to the real world, and then we think about enhancing them, if you think this way of learning works for you, it makes a subject more interesting to you, do look at our website www.wibyte.in because that's how we learn Python programming. Take care. Thank you so much. Bye bye.